This is problem number 55. The head of water over an orifice of diameter 100 mm is 10 meter. The water coming out of the orifice is collected in a circular tank of diameter 1.5 meter. The rise of water level in the tank is 1 meter in 25 seconds. Also, the coordinate of a point on jet measured from vena contracta is 4.3 meters horizontal and 0.5 meter vertical. Find CD, CV and CC. This problem may seem very difficult one, but if you remember the concepts related to the experimental determination of CD, CV and CC, you can very easily solve this problem. So the problem is like this. We have a tank with an orifice of diameter 100 mm. So there is a tank with an orifice of 100 mm. Now head of the orifice is 10 meter. Let us mark that also is 10 meter. Is 10 meter. And the water is coming out of the orifice is collected in a circular tank of diameter 1.5 meter. Diameter 1.5 meter. This is a circular tank and this is a jet that is coming. Now rise in water level is 1 meter in 25 seconds. I hope you all understand what this means. This means that for every 25 seconds 1 meter is getting risen. Okay, so the level is increasing by 1 meter at every 25 seconds. Now there is a point on this jet and the horizontal and vertical coordinates are given. So before solving this problem, you need to draw the figure. I have drawn that figure. So this is the tank, the orifice, the circular tank that collects the tank. So if you remember the experimental determination of CD, CV and CC, you can easily solve this problem. So let us start with CD. CD is equal to, CD is nothing but actual discharge by theoretical discharge. That is actual discharge divided by area of orifice times theoretical velocity. That is in turn equal to actual discharge by area of orifice is pi into d square is 100. Pi d square by 4 into root 2 into g into 10. Let me find out the theoretical discharge. This will be equal to actual discharge divided by (0.109). So I am writing CD is equal to actual discharge divided by 0.109. Now how to find out actual discharge? CD is equal to actual discharge divided by 0.109. Now how to find out actual discharge? In order to find out the actual discharge, they have said that the water coming out of the orifice is collected in a circular tank of diameter 1.5 meter. The rise of water level in the tank is 1 meter in 25 seconds. Now the unit of discharge is meter cube per second. That means it's the volume collected per second, or it's simply volume per second, isn't it? Nothing but volume per second. Meter cube per second. Meter cube is a unit of volume. Second happens to be second. So it's a volume collected per second. So here they have said that there's a circular tank and it collects the fluid. And the rise of water level in the tank is 1 meter in 25 seconds. So let us see the rise of water level in 1 second. 1 meter in 25 seconds. Therefore, 1 by 25 in 1 second. One by 25 in 1 second. So for every second, 1 by 25 meter of fluid is collecting. Okay. Now, they have said that this is a circular tank of diameter 1.5 meter. So considering this concept, volume collected per second, let us find out the volume of water that is being collected per second. To find out that, we need the area of the tank and we need to multiply it by this value. Or simply you can write Q is equal to A into H by T, where H by T is the fluid collected per second. Therefore, area is equal to pi into d square by 4 into 1 by 25. This will be the actual discharge. This is equal to 0.07068. Therefore, CD will be equal to 0.07068 divided by 0.1099, which will be equal to 0.643. Either you can use this equation or you can use this concept. Both are same. It's the volume collected per second. So you have to find out the area from the diameter and you have to multiply it by the volume per second. Sorry, the rise in level per second. The area times rise in level per second. Now let us find out CV. CV is equal to actual velocity divided by theoretical velocity. And also CV has another equation that we have found out while discussing the theory portions of experimental determination of CV, that is x divided by root of 4yh. Value of x is given as 4.3. This 4.3 and this 0.5. CV is equal to 0.96. And CC happens to be CD by CV. We don't have a direct way to find out CC. We have to find out it from CV and CD. 0.669. So that's how it's done. So to find out CD, you have to have this idea in your mind. It's a discharge is meter cube per second. It's nothing but the volume collected per second, and we have multiplied the area with the rise in level per second to find out meter cube per second. It's same as this equation. We have multiplied area with rise in level or fluid collected per second. This is meter square, this is meter per second. Multiply, you will get meter cube per second. Area is meter square and h by t is meter per second. Multiplying, you will get